calculus 2 sequence and series reuse. So yeah, so this will be all about before the Taylor series. So yeah, let's continue with sequences. So number 6, we got to find the summation from n equals 1 to infinity of n uh, n factorial over 3n. Oh my gosh, I forgot this symbol. That little apostrophe means factorial. So what method should we use? So here's a big clue. Since you have a factorial, you automatically have to use the ratio. So if you have a factorial, just use the ratio test. That's what I'm going to do. So how do we do the ratio test? First, replace n with n plus 1. Then what you're going to do is multiply top and bottom by the reciprocal. So we're going to write this as the limit as an approaches infinity, the absolute value, and then place n with n plus 1. So now this is going to be n plus 1 factorial over place this n with n plus 1. So that's going to be 3n plus 1 times the reciprocal of the top and bottom. So go back to your original, and what's the reciprocal of this? It's going to be 3n per n factor. Okay, so how do we do this? So what do we know? We know that n plus 1 factorial is the same thing as n plus 1 times n dot 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 until you hit to make. We also know that n factorial is the same thing as n times n minus 1 dot 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 until you hit. So we also know that this 3 raised to the n plus 1. Remember your exponent rule? It's going to be it's the same thing as 3n times 3 times. So what happens is when you use this rule right here, uh, eventually this n factorial disappears, and then n this factorial disappears. So this n factorial disappears, and then this factorial disappears, and then you're left with this. The limit as n approaches infinity, the absolute value of parentheses n plus 1, right? This factorial disappears. You're still left with this 3n over 3n. This doesn't disappear, 3n times. Happens is now you have the absolute value. So you're left with n plus 1. The absolute value. Absolute value now just turns into 2. See, we print these numbers. You see that. So infinity plus 1 is infinity. 3 infinity over smaller number is still infinity. And well, we know that also we know that the limit and then infinity of the absolute value of a n plus 1 and so that so someone says which of the following series converges? Is it Roman numeral 1, the summation from n equals 1 to infinity of negative 1 raised to n over n squared? Is it Roman numeral 2, the summation from n equals 1 to infinity of 1, the square root of n cubed? Or is it Roman numeral 3, summation from n equals 1 to infinity of 1 half raised to the n? And her choice is A, 1 only, Roman numeral 1 only, B, Roman numeral 2 only, or C, Roman numeral 3 only, or D. D says numeral 1 and 2. I mean, Roman numeral 1 and 3. Or is it E, just 1, 2, and 3? Okay. So, how should we do this? So we should use our riddle. Nice penguin goes camping in the Arctic region. So N E E. This penguin goes camping in the Arctic region. Let's see. One, we have negative 1 raised to the n over n squared. We know that converges. What about Roman numeral 2? We have 1 over the n cubed, 1 over the square root of n cubed. So we could kind of write that as a p series, right? Wait, the reason why Roman numeral 1 converges is because it's an alternate series, right? Because it has that negative 1 raised to the n. That's an alternate series, so we know that converges. Roman numeral 2, we can use a p series. It is in the form of a p series. 1 n cubed is the same thing as 1 over n raised to 3 halves, right? Square root of the square root of n cubed is the same thing as our n to the halves. Okay. Now, because our p is going to be 3/2, it's technically greater than 1, so we know that converges. So far, Roman numeral 1 works, Roman numeral 2 works. What about Roman numeral 3? What kind of series is Roman numeral 3? It's 1/2 raised to the n, so it looks like it's a geometric, right? This right here is a geometric series. It can be written as 1/2 raised to the n. And because the n is 1, right? This n is to the power divisible. Because our n is to the 1, and our r is going to be, r is less than 1, but greater than -1, just r, in our case, r is 1/2. Yeah, it is less than 1, but still positive. So that means it converges. So it looks like all 3 converges. So I'm going to say letter E. 1, 2, and 3 are all. Says which of the following series converges? Spatial. It's 2. It's pi over n. 3. Summation from n equals 1 to infinity of 1 over n. And the choices are A, 2 numeral 2 only, B, 1 and 2 only, C, 1 and 3 only, D. Okay, so let's just test each one individually. So let's start with Roman numeral 1. What kind of test shall we use? Can you write down the riddle to help you figure out which test shall we use? Nice payments go. Campaign. So we have some kind of rational function. So it definitely, we can definitely use, since it's an irrational function, we can definitely use the n term. So write this as two, and replace that with infinity. This would be infinity over infinity, which is really just one sin. So that definitely diverges. So yeah, one converges, so we can't use one because that diverges. What about Roman numeral 2? What kind of graph? If you kind of graph cosine graph, this is technically a cosine graph. I think it's oscillating and it's never going to converge to anything, so it's going to diverge. So it's going to diverge. Right? You have some kind of sine graph, sine it starts at max. Down. Since it's oscillating, it's never going to converge to anything, so it's going to diverge. Yeah, because we have no boundaries. Okay, Roman numeral 3. Summation from n equals 1 to infinity of 1 over n. it's a harmonic P series, and since the yeah, this is a P series, and since yes, the P is one, it's going to diverge. So this is a harmonic series. We know that. So it's going to be letter D. It says for what value of K, where K is greater than 1, will both uh, summation from n equals 1 to infinity of negative 1 kn, and summation from n equals 1 to infinity of k over 4 converge. So which of these will both converge to? So got to figure out what k value that will make it able to. So we can start testing because like a voice. You have A 6, B 5, D is 3, and I mean A is 6, B is 5, C is 4, D is 3, and then E is 2. So they give us the choices. We got to figure out which K values will make them both converge. So what do we? If you look at the first summation, you have n equals 1 to infinity of negative 1 raised to the kn. I think I think it has to be odd. Uh, yeah, I think our k value must be odd because if you replace your k for this one, for example, if we use b for 5 because it has to be odd, you get negative 1 raised to the 5 raised to the n. And well, if you want, you can take out that negative 1. So this would be negative 1 raised to the n, and then zero. So, yeah, I think it has to be odd. Our k value has to be odd. So I think 8, 6. We can eliminate E. E is even. So, the only choices are I. Yeah, I don't think I will. I think it would be 3 because if you look at the other one, we have the summation 3 a. So the k over 4 is a number. So it's like saying a number raised to the n. That is a geometric series. And if you look at the ratio, this one right here, it's going to be r raised to the n, where it's negative. So I think our k has to be 3 because it has to be less than 1 but greater than negative 1. So I think if K works, yeah, K of 3 will work because R has to be less than 1 than negative 1. So yes. 5 won't work because 5 is, yeah, it's not gonna work. And the sum of the series of the summation from n equals 1 to infinity of 1 over n times n plus 2. So what do we know? There's two tests we can use because it's a rational function and we want to find the sum. We can do either we could do geometric, do telescoping, and yes, you can technically do Taylor. So I think this is going to, well, let's try, I think we're going to use telescoping, and the reason why is because this is a telescoping since it's a fraction that can be broken down into a smaller fraction decomposition. So it looks like we have to do some kind of partial fraction decomposition. So yeah, if we're dealing with partial fraction, that's how you know how to do telescoping. So let's break this down. So we have, let's decompose this fraction. So we have 1 n times n plus 2. And it's going to be a over n, b plus a and b, right? Do first, maybe I would do is get rid of the fraction. I'm multiplying all sides by the LCD, which is n plus 2. So over here, what happens is that just becomes 1. Here, what happens is the n cancels, and you're left with a times n plus 2. Here, it cancels, you're left with n plus 2 cancels, you're left with bn. So now we got solve for A and B. So what I could do is, what shall I do? Test it value. So maybe we can test 7, 0. Maybe so 0 plus 2 is 2. And B times 0 is just 0. So we get 1 equals 2a. And solve for a, so we do it. So 2, get a equals 1. Okay. And then what we're going to do is solve for b by setting n equals to -2. So it's going to be equals a is n b times that's 8 times two, 7 times 8. Part A would be, oh, now we would do, value. You have a complex fraction, so if you want, at best, it's best to simplify this before further. So this part, it's one half divided by two. So this n has its denominator one. We can use the bracket method, and then this has a one. This is a two, so my house is two. Why all? Why two times one half is going to be two times that is 200. And I just factor out the two later, and then minus two. So this two times negative one. Two times negative one half is negative two times n plus two. That's two times n plus two. It looks like yeah. So you have negative one half two times n plus two, and yeah, I think you could factor out that one half. Yeah. So you start plugging it in when n equals one, since you're going to get since n equals two. It'll be you simplify that, uh, it's going to give you one half, three halves. Letter A. You find the sum of, so we have the summation from n equals zero to infinity of two times negative two thirds raised to the n. So you got to find the sum. So what do we know? We know that this is going to be geometric since the number is raised to a variable. Okay, so we know that this is going to be so how do we do the summation? I mean the geometric, it's going to be to find the sum of a geometric series, it's the first term over 1 minus ratio, right? So my first term is my first term. The first term is, so my first term is going to be 2 times 2/3. So it's start at 0, which gives you 2. That's 2 minus my ratio. My ratio is, I think my ratio is, yeah, my ratio is negative 2/3. So it's going to be minus 2/3. Here, 2 negatives becomes a positive, so it's 1 plus 2/3. I'm going to simplify this because you have a expression. What's 1 plus 2/3? Well, I can rewrite 1 as 3/3. So that's going to be 2. So that's 5. Simplify 2 divided by 5/3, that gives you 6/5. So sum will be 6/. Let's use the summation formula geometric series. Oh, let's find the sum of the series. Find the sum of the series. So we have 2 negative 2/3, positive 2/9, negative 27. I mean, negative 2/27, and then it's dot, dot, dot. So find the sum of the series. So what do we know? Is this a geometric or arithmetic? I think it's a geometric. How do we know it's a geometric? It looks like we have a common ratio. And how do I find this common ratio? What you could do is take the second term divided by the first term. So my second term is negative 2/3 divided by my first term, which is 2. We do. And this is how I know it's geometric, is because if you multiply each term by negative 1/3, so if you multiply 2 by negative 1/3, you get negative 2/3. And then if you multiply negative 2/3 by negative 1/3, you get 2/9. And then 2/9 times negative 1/3 is negative 2, negative 2/27. It has to be consistent, right? So this confirms that we do have a geometric series and the common ratio is negative. So how do you find the sum of a geometric series? It's basically first term. My first term is 2. 1 minus my ratio. My ratio is negative 1/3. Let's get 2 negatives becomes, and plus 1/3. Well, I know 1 can be expressed as 3. So 3 plus 1 is thirds. So it's 2. Make 3 times 6 times 4. 6 over two. That's which of the following sequences are we have Roman numeral 1, 5 over n to 200 minus 1, Roman 2, e raised to the n over n. From 3 e n raised to e raised to the n for 1. So for sequences, there's only one. You can try plugging n for infinity, and then if it's a tangible number, yeah, if it's when you plug in, you could try plugging it in n for infinity, and so let's look at Roman numeral one. It's a rational function, and so basically they're asking you, in a rational function, do you have an asymptote? Yes. It can be limit as n approaches infinity. You just look at the highest term on the numerator and the highest term on the bottom. So what is the highest term on the numerator? It's 5n. And what is the highest term of the denominator? Is 2n. And look at the powers, they're both to the power of 1. And what happens when those degrees are the same? You use the coefficient. So that's going to be 5x. So this is a tangible number. So 1 works. What about Roman numeral 2? Let's see. Let's try a limit as n approaches infinity. En. We could try replacing that with infinity, right? We could try that. We have what's e to infinity? Infinity, just infinity over infinity, just indeterminate form. So what happens when we have an indeterminate form? Try another method, and because it is a rational function, we can try find Lagrange rule. So basically, Lagrange rule just means take the derivative of the numerator and denominator maybe once, maybe twice until you get a real number. So let's try the first derivative. So on the numerator, what's the derivative of e to the n? It is e to the n. And what's on the bottom, what's the derivative of n to the 1? Just 1. Now let's try plugging e to the e raised to the 1. And believe it or not, e raised to infinity is infinity. Infinity, so this is not good. Wait, no, it doesn't. What? Right. The massive converges. This diverges. What about over we have e to the n over 1 plus e to the n, so let's do that. So it's going to be the limit as n diverges e. And if you by plugging in for an n for infinity, you're going to get. So you try apply a top again. Basically, you take the derivative of the numerator and denominator maybe twice. So on the numerator, what's the derivative of e to the n? It is e to the n. Bottom, what's the derivative? Now, what's e to the n over e to the n is just so now you have a limit as n approaches infinity. So it looks like one works in, yeah, D. D is in this, it should be one and three. So D is actually one and three, so it's letter D, right? So one works, two does not work because it diverges, it gives you infinity. Three works after applying Lagrange's rule. So it's just one to three. Let's do one. Okay, number two says find a formula for the nth term of the sequence and start with n equals one. So, yeah, we can find it with one. Sorry, it gives you a number. I didn't write that down. So our numbers are -2, eight, up. What we have to do is from our choices, A, B, C, D, E, we gotta find the end formula. And so our first term has to be -2, our second term has to be 4, our third term has to be -8/2. So it says start with n equals 1. So let's see if that works. So let's start with when n equals 1. And so basically, let's test each value and then let's start with n equals 1. So this would be -1, and then replace n with 1, so 1 plus 1 is 2. It's 2, and it's 1, so 1 plus 1 is 2. Then -1 squared is 1, 2 squared is 4, 1 factorial is 1, 1 times 4 is 4, which is, yeah, that is not going to work, right? We want the first term to be -2. So I don't think it's a. Well, let's start with n equals 1. So this is going to be -1, and then equals 1. 1 plus 1 is 2. 2, so that's 2 squared. So that is 2. 2. -1 squared is 1. This is my first. -4. So it's 1, 2, it's -1, there's 2, that's -2. Okay, so this works. The first term gives you -1. Does it give you, it has to be consistent. Does the second term give you 4? So let's try it. Let's try n equals 2. So it's negative. So -1 squared is 1. 2 squared is 4. 2 factorial is 2. Times 4 is 2. That is 2. No, second term should be 4, so it's not C. D, I didn't write this down, but D is -1 raised to the m times 2, wait, times 2 raised to the n. So let's start with n equals 1. So it's going to be -1 to the 1, 2 to the 1. So -1 to the 1 is -1. This is 2. 1 factorial is 1. What's -1 times 2? 1, that's -2. Yes, that gives us the first term. Now let's keep going. Let's try when n equals 2, and if that gives you 4, and then it might work. So let's replace n with 2. So it's -1 to the 2, 2, 2. It's, why did it put 2 here? This is, wait, sorry, I was looking at the wrong about D. So this is actually 2 minus 1. Oh, sorry, this is 1 factorial, right? Because what's 2 minus 1? Yes. So far, so good. So we have -2 and 4. But what about the third term? Does it give you -8/2? Let's just make sure. Minus 3 minus 1 is 2 factorial. This is going to be as term negative. Yes. That would be the last one. And it's over. Just to be done, just to make sure that n equals x minus 3. So let's stop here. In the video.